talking about browsers and front end, and the front end room's over there, but we'll see how this goes. Good afternoon. My name's Phil Nash, and I'm a developer evangelist for a company called Twilio. Can I just start by asking, like, has anybody here heard of Twilio before? I just pop you. Not too many. Okay, cool. For those who haven't, Twilio is a communications platform. So it's an API for your applications to communicate or connect with your users via voice, video, or messaging. We actually just released a fax API, so we've brought it back to 1987 as well. Admittedly, we released it on April Fool's Day, but it's actually no joke. It's carrying on. So if you need to send fax from your application, you can go ahead and do that with Twilio right now. Promotional things aside, we're not obviously here to talk about Twilio, although it might come up in my demos, because that's the kind of thing I end up writing. What we are talking about is browsers, and what they can now do behind your back when you're not looking at a page, when you're not part of it. And I want to start by saying that email, sending an email, I think, is pretty cool. I don't mean email being cool like it's that to-do list that somebody else can put items onto. That's not so cool. But I really like this kind of interaction where you can start writing an email and then send it, and you can close your application as soon as you've sent it, and you might not even be online when you do so, but you know that that email is going to get sent in it eventually. You just don't have to care about it. Press send, close the app, gone. What would happen if you did that with a web app? You might send the message, you might send the thing, you're not entirely sure. You might have interrupted the browser before it's finished its request. If you are offline, you're probably not going to be too happy either. That's just a request that's not going to go through. So on the web, that's an unknown experience. In fact, it's normally a really bad experience. And we've been talking, a lot of people around the world recently have been talking about making websites work better offline. If you're in here, then you probably heard a bit about the service worker before. And it's really good, a really good bit of JavaScript that we can use that can make things work offline. But it's really, up to now, been around caching and keeping files offline and hitting pages. And we've been building these progressive web apps that have a more app-like nature to them. But, as I said, it tends to be the ability to load a page when you're offline, and not say, and avoid this guy, right? The very disappointing dinosaur game that you get if you are offline. The Downosaur, I think it's called. But what if you're sending messages? What if you're making these post requests? What if you're liking or favoriting something? Adding shopping to a cart, leaving a comment, just things where you have to make a post request, where you want something to change on the server, but you're offline. Currently, that experience is still running dinosaur game, and everything's a bit sad. And I want to tell us how we can change that today, how we can make this better. Because we now have available to us the background sync API. There's actually a few background things going on right now, and we'll get to more of them at the end. But this is our thing for today, background sync API. And so it's made up kind of three things. We still need a service worker. It's in fact just an addition to what service workers can do for us. I think we need a handle on IndexedDB. And if you were in the front-end room earlier this morning, I was talking about how I think IndexedDB is important to offline applications as well. And this is one of those reasons. And we'll see how this fits in later. And finally, we get the sync event. And this is that addition to the service worker that we're looking for. And I'll explain how it all works. So let's start with a demo. I just want to show you what I'm expecting to see work by the end of this. And you have to excuse me, I am going to do a bit of typing, and I might have to put the microphone down at times. I'll try my best to speak up so you can hear me. So hopefully even the recording can hear me, even if the microphone's sat down there. But right now, I have this application. It is a very simple SMS sending application. It uses the Twilio APIs to do so. And then this is my phone on screen, and the number I'm expecting to get that message from. So at the moment, I can send a message to it. And what it should show is that things work. There we go. And a message should come through over here. There we go. Brilliant. OK, that is our demo application for the day. And we are going to make this message form work regardless of the internet connection available to it. Cool. So let's talk about the service worker then. Up until recently, up until about 2 years ago, browsers were mostly dealing with pages simply by asking for them from the servers. That's all we had to do. You expect your user to be online, you ask for a page from a server, you send some data to a server, you get that back. And that's changed with the service worker because it sits in the middle. It's that proxy that we are in control of that allows us to, we can generate requests, we can generate responses from our service worker file, even without going to the server. Or we can go to the servers. We can do whatever we want with it. We can put stuff in caches. We can get things out of those caches. The service worker will respond to any fetch event, any request made by your page, and allow it, and return a response to it so that we can then show that back in the browser and avoid the dinosaur. But now we have this bit of JavaScript that runs in the background. It allows us to do other things. One of the key things for that, which is available on a fair few browsers right now, is push notifications, in which the service worker can receive a push notification and then notify the browser of that and notify the user. And it's because we have this in the background, so once you're off the page, the service worker can keep doing work for you. So let's build a service worker onto our page right now. This is the first time I'm going to put this down, I'm afraid. I'm going to jump into the code here. Can you read that? It's a bit of a weird color, I think, but I think it's readable. Is that cool at the back? All right, so I've got a couple of methods here. I have one method here which basically just pulls things out of fields in the DOM and makes a message. I'll put that down. Shout if you can't hear me. So when the page is loaded, I'm going to make our service worker. I'm going to install our service worker. So I've done a quick check already to make sure it exists. But now I'm going to actually install it. And we do so by calling the register method on service worker on navigator. And our file is called swjs. We could give it a scope at this point, which would scope it to a part of the application based on the path that you put in there. But we don't need to do that right now. It's not important for this. Service workers absolutely love promises. So we're going to return a promise from that. And so you can run the then function on it, and once then is called, then our service worker is installed. I can get excited about that. And if things don't work out as we'd expect, if the service worker fails to install for some sort of reason, then we'll get an error for it, and I will just log the error as well, just to make sure that that's okay. And that is all we actually need to do to register this service worker. And here is where the next stuff is going to go. I'm not going to load that in the page right now, simply because it doesn't really do much. Let's go back to the slides. Because this brings us to IndexedDB. When we're trying to deal with this message, with this form that we're going to submit, which has a bunch of data that we want to send to a server, we actually need to store that data somewhere if we're going to do it sometime later, if we're going to do it in a background sync. And IndexedDB is pretty much the only reason for this. As I said, I went into depth on it, the only way we can do this. I went into depth on it earlier, but IndexedDB is our one and only kind of browser database that we can use for this method. We can't really, it would be nuts to use cookies. That's a terrible idea. Local storage would be nice if we could use that nice simple synchronous API, but that it's a synchronous API fails us in the terms for service workers. Service workers pretty much require everything to work asynchronously and with promises. And so local storage just doesn't work for that and is not available within either service workers or normal web workers. It is an object store, so you can put JavaScript objects inside it. You don't have to stringify things to JSON like you would with local storage, so that's a good thing. It's asynchronous, so that it does work with our service workers, which is good as well. And it's transactional, and this we won't see actually as part of this, but what it really means is that when you try and make things happen in IndexedDB, you're just basically asking the browser to go sort this transaction out. And that's why it comes back asynchronously. You end up with a queue of transactions, and callbacks run when those transactions are complete, or when they error. And it's kind of low level. It's It's not the friendliest of APIs. And it's very much, it even says, I think, in the spec that this is very much a useful thing for building libraries on top of. So some libraries. I recommend you use them because you don't want to have to deal with the hassle of IndexedDB nor some of its bugs. Especially when you want to deal with the service worker as well, because service worker, as I said, really likes promises. The normal IndexedDB API works with a bunch of weird callbacks. However, IDB is a library written by Jake Archibald, which wraps up the IndexedDB API in a promisified manner. So we can use promises. And it's actually a little bit more sane than the old IndexedDB callback system. We also have local forage, which is a key value kind of store. It's a replacement for local storage. Dexy, which is a bit more fully featured for an object store. And PouchDB, which is it's pretty much an implementation of CouchDB in the browser, all the way up to the ability for you to sync back to a remote CouchDB instance, which is kind of cool. And as I said, service workers love promises. This is the callback, interesting callback stuff that you can have with IndexedDB, where you open a database and then you start making callbacks appear on that database's requests. It's a bit awkward. And that's not even all of them. I missed the error one in this case because I ran out of space on the slide. But promises are much nicer. And this is IDB. This is Jake's library there. You open it up. You do get a callback to say, OK, set this database up. But once it's open, then you can just go and deal with it. So let's use IndexedDB to save the stuff from our message and not send that message in the first place. So I'm going to jump into this part. So this is my service worker successfully registered. And I want to check if that registration has, there we go, we want to check if sync is in reg. This is the service worker registration. And sync is the background sync API that we're going to get to eventually. If this doesn't exist, we don't want to do anything with it. Now we have a form, which I got earlier, to save again, John manipulation in this. And we're just going to add an event listener to submit. Submit. And stop that from actually submitting. And once we've done that, we can then open up our database and put the message inside it. This is the best way I've found to do so far. Now I have a little extra wrapper around IDB in which I am doing some of the boilerplate stuff, so we don't have to see that. But I'm going to open up our outbox of the store in read-write mode. That is a promise, so I'm going to return it and carry on below. Nope, no, I'm not. That is a promise. We're going to then on that right away. And at this point, we get access to our outbox. So with our outbox, we just want to put the message inside of it. Makes sense. This is just a simple IndexedDB call. And I have that method from above, get message from form, which just returns an object with the two fields in it. And that is adding things into IndexedDB. We can take a look quickly at the store. It's very simple. This outbox function simply calls store.init, which really does the opening up and creating of stuff, and then does a transaction and gets the object store and returns it all. It's not a big wrapper whatsoever, but it does make things a bit simpler than doing all that over and over again inside the application code. So cool, that's putting things into IndexedDB. I can run this, actually. Let's go do that. And what we should be able to do is try and send a message. Hello again. And this one should go nowhere. In fact, it should go inside the database here. And that is our message. There we go. Hello again. So we are now storing our message within the database. We're not doing any clear up work in the form, but we don't really have the time for that. Cool. So we've got our message stored in IndexedDB. This brings us to the background sync API. This is the most exciting part. The background sync API, I think, has a weird name. Because it sounds like it can be just doing stuff in the background over and over. It sounds like it can be running, using up your battery, using up your signal and everything like that, when in fact, really, it's a one-off API. What it really means is, if you call for a sync event to happen when you're in this state, when you have no connectivity, it will run once you get connectivity again. Once the browser, once the thing itself is connected back to the network, your background sync event will fire, and you can do stuff. And it's only going to fire the once. So to me, it's kind of more of a back online API. Of course, if you do try and run a sync event when you are online, it will fire immediately, pretty much, because you are online. You're already back online. So to me, it's very much the back online API. I should mention some browser support for this, because it's only really supported currently in Chrome 49 and above. As you can see, even from the way I'm building it, though, if we're checking for the existence of the sync object, we're checking for the existence of the service worker, it is a nice progressive enhancement to our application. And if the service worker sync, if the background sync API is not available, then that form is going to continue to work exactly as it would if you had a browser that didn't support it, which is, of course, all the rest of these. However, there's good news about it. If you don't know this, anybody know the purple logo, actually? Any ideas? It's the Samsung Internet Browser. It's available on all new Samsung Internet phones, Samsung phones, and actually can be installed on Nexus and Pixel devices now, I believe, as well. It might seem like it's a weird one, especially if you've not seen it before, but it does cover about 10% of the mobile market now because it's the default browser on new Samsung devices. So it's worth considering. And in the beta of it, 5.4 beta of Samsung Internet, it is actually, we have support for the service worker background sync. I asked about this, and apparently there's a bug in this beta version, but it will be fixed by the time it's actually released. So that's kind of good news. And then Firefox are working on it. There is a gigantic bug in Bugzilla with all the kind of things that need to get done, and they are actively working on it as far as I can see. The Edge team are working on it, which is really cool. I met a couple of people from the Edge team just this week, and we are getting so close to the release of Service Worker in Edge in general, and we'll include the background sync APIs. So that's kind of exciting. Opera are also working on it, although weirdly enough, I can only find that out from the Edge website, because I don't know why. And then Safari. So, I mean, they're behind closed doors and they don't get to talk about it that much, and they're probably working on service worker things, but who knows? I mean, who knows when we'll ever see it? Eventually, I'm sure we will. I'm pretty sure they're working on it, but we just don't have any visibility on that. So for right now, iOS devices are going to continue to live without the service worker and without all these exciting new capabilities. I do think they are going to do it. iOS Safari does support app cache, the old way of making websites work offline, so I don't think Apple has anything against offline web applications. That's a thing. And if you kind of think, these progressive web apps are going to start to compete with the App Store, then also consider that Apple recently released Apple Pay for the web. So you can pay for stuff in the browser now, and that goes through them. So they do have good reasons to support the web now, including the fact that it'll make them money. So I'm sure it will come. But that's our support for now. Progressively enhance this. And this is how it works. So once we have our service worker, and we've seen our kind of, ready is also quite a useful thing. It's just a pointer to the promise from the original service worker registration. And so that will always, you can always use this to get hold of the service worker at any point. And then when you want to register for a sync event, that is something has happened, like the form submit, we just call sync and register. And we add a tag here. In this case, I've just called it back online. But this tag means that you can register multiple sync events and then do different things with them when the sync event fires itself. And so then in the service worker, you just have to listen for the sync event. And this is where you can check for that tag as well. And that's kind of it. So let's do it. Let's install, let's make this service worker work. So at this point, I'd put the thing in the database. And when that successfully returns, or when that actually returns from the promise, we should be able to then register for our sync event. There's no point in registering if it fails to go in the database. So at this point, I have reg, and I will call sync.register. And I will just call that the outbox tag. Although this is going to be the only sync event in this particular application, so I'm not going to be checking for that later. And that's kind of all we needed there. So here's my service worker. Up the top, you can see I'm importing IDB for the database promises stuff, and then that store file that I showed you as well. And these are just the request headers that I'll be passing down. I didn't want to have to write that out. So we are going to call on self. Self is the service worker itself within the within this file. And we're going to listen for the sync event. And we've got a bit to do when we get this event. First of all, we have to tell the service worker to wait, because the service worker is in that position where it could be killed at any time. It's running in the background, but if we want it to do something, we have to tell it to wait. This is something we really want to happen. So once we've done that, wait until takes a promise and is only over once that promise resolves or rejects. So I'm going to use this point to open our outbox again, this time in read-only mode. And get the messages out of it. So this could have multiple messages. So we will have to run through them. In fact, we will see multiple messages because I've already tried to send one. So there's one in the database already. So let's return the outbox.getAll. This is just a message. This is just something that runs over all the messages in the outbox and will return an array of messages at the end. If you saw me talking earlier, you'll know that IndexedDB actually works with a cursor, which just pops one off the list at any one time. This is just getting hold of all of them. So we'll get a bunch of messages, and at this point we need to do something for each message. So I'm going to use promise.all over the messages to deal with that, because we're going to map another function, which is going to take a message each, and we are going to send that down to the server using the fetch API. If you've not seen the fetch API, this is now available even in Safari on iOS in the latest 10.3 version. So that is pretty cool. No more do we have to, in any of the major browsers, do we have to deal with XML HTTP request. And to that fetch, I'm also going to pass options, which include the fact that I'm making a post request in this case, and the body will be my stringified message, and then the headers will be the request headers that I've loaded above. So we're going to return the fetch of that, but when that happens correctly, then we also want to delete the message from the database so we don't send it on again. So I'm just going to open up the store in read-write mode this time. Return that. Open up the store in read-write mode, which will get me the outbox, and then use that to, let's make sure that's high enough. Oops. Use that to delete the message by its ID. So that's kind of what we're doing there. If I just run back over that again, we're opening up our store, opening up our database in a read-only mode. And once that's open, return all the messages from it. Once those messages are returned, then we'll map over those messages and return a promise that actually is the result of sending a post request to the server, getting that post request back, opening the store in read-write mode, and then deleting that message. Once that all happens successfully for each message, promise.all will resolve, and we have finished our business with the database. So that's cool. That should work. But before I actually show that working, I do want to bring up a couple more things. The future. Because it's not just background sync, this background sync API that exists now. There are more people thinking about more stuff. And I found out actually that at the weekend, and this was not, as far as I can tell, an April Fool's joke, we actually have the background fetch API. This one is also a difficult name. This one really exists so that we can use service workers and again, an ability to run things whilst the browser and whilst the page is actually closed. Ability to run large downloads in the background in this particular case. So this is so that you can build kind of a large media site, for example. And if you want people to download MP3s for podcasts or MP4 videos, things like that, then you can actually use the background fetch API and call fetch on it. This is still being worked on. This is, so when I say released, I mean behind a flag and only 3 days ago. So this is kind of new. This is why I'm looking at it as well. I just found out this morning. So you can pass a URL, or in fact a list of URLs to this, and then some other bits like some icons, so that can show up an icon that your application is doing this downloading in the background. Having a title for that, and then this is kind of a hint to the size of the thing, so that the UI can, in the browser, can instantly kind of show a guess of how much time it's going to take. That gets taken over when the browser actually receives the real content size from the headers of the file themselves. And you can do as I said, you can do a list of URLs in this case. Again, you get a tag that you can go and look these things up at. So you can go and look things up later, both in your UI and in the service worker. And in the service worker, background fetched is the successful result of fetching all of those URLs or request objects. And you can use event.updateUI to actually to tell the UI, tell the browser UI, everything's happened. So I think that's quite cool. And there's some other events like background fetch fail if one of the list of URLs or requests fails. Background fetch abort if the user cancels it. Background fetch click, which can, in the example of downloading a podcast in the background, you could maybe take the user to that podcast page in your application, whether it's downloaded or not. Inside the spec document, there's actually some pretty good examples of a whole bunch of use cases. They seem to tend to be around podcasts, but one of the interesting ones certainly was the ability to actually play the podcast whilst it's downloading in the background. And I think that's really interesting. This also works for uploading as well, so you can upload large files to a server via the service worker as well and get all these events for it. So that's kind of cool, I think. And then there's the periodic sync API. Now this is the one that we can have running in the background over and over again. Very useful if you are doing some kind of news site where if you want once every day to update the latest news, perhaps before your user tends to wake up. So when they check their application, they have all that news loaded there in front of them without having to even hit the network to get it. And this one, again, looks kind of similar. So we have a registration, and we call periodic sync on the service worker registration. And this one is absolutely still in design mode. Like we don't have anything, there's nothing in a browser that you can turn a flag on and check this, as you could do with the background fetch API. But it's just interesting to see where we're going. So I think what might change, for example, is that you have a tag in the options here, whereas in the background fetch, you put the tag as the first argument. And then you can do some other stuff. So this is the minimum period of the background sync, the periodic sync. Minimum period means that it's not going to run any sooner than that. However, this is not an alarm API. You cannot get exact timing out of it. This is just, it will probably run once every 12 hours in this particular case. Again, power state and network state are options that have been made available, it seems, to the background fetch API, but I don't think they're implemented yet. And that's because they're not sure on the names yet. They're not sure exactly how to do it. But the idea is that they should be able to, avoid draining, I think, would not run if your device was in battery saving mode, for example. Avoid cellular means that you would only do these syncs if you're on a Wi-Fi network. I think that's kind of sensible stuff, especially given that many of these APIs are, they work much like a native application on a mobile device does, so that it works with mobile devices and considers a mobile device and the fact that you might do bad things to them if you happen to do a particularly power-hungry activity. These APIs have been designed for that. And then, so on the service worker, this looks exactly the same almost. We have a periodic sync event, and that's it. You can go and make your fetch, make your request, go get the things you want to put probably into IndexedDB or maybe into the caches API, and that's it. You'll have that ready for the user next time they use the application. So that's kind of the future. You can go test out the background fetch API right now by going and switching the experimental web features flag in Chrome. You can't test out the periodic sync API yet, but if you have strong feelings about it, you can certainly leave those on their GitHub spec page. But in the meantime, we should see if all the code I wrote worked, and if we can get those final messages sent through to my device. So, I'm going to refresh this page here. Just make sure our service worker has updated. I think it has. That's got all the stuff in it. Seems to have installed correctly. We can also see that we have one message waiting in the outbox. However, we have not registered for a sync event yet. And that's why it's not gone anywhere. So I'm just going to turn the Wi-Fi off to simulate my poor connectivity or whatever. And send this message from offline. If I send that, then we should be able to refresh IndexedDB and see. Oh, IndexedDB, it's never going to work, is it? Yeah. I actually believe it's in there. It's just the dev tools are not that happy. And what's exciting actually is at this point we can actually close that. We can't close Chrome entirely because then nothing will run. Not on the desktop anyway. On Android devices you can close Chrome entirely and they will run sync events and push notifications and things like that. So I have Chrome open, as you can see, just not on the page that we were playing with. And if I turn the Wi-Fi back on and we connect, we've connected, we should start to see the sync event will be fired. We'll go into the database, fetch the things, send 2 fetch requests down to my server, which will then send it on to Twilio, and finally text me. Ah, yes. Right at the end. All right. Let's see. Where's it gone? I sounded so confident though, didn't I? It was a good plan. If we look inside IndexedDB, they've gone. Interesting. But they haven't arrived at my phone. That is interesting. This happened to me before, but I don't know what's happened here. I tell you what. Oh no. Ah, okay. I spelt the URL wrong. Cool. That's the best thing that could have gone wrong. So we got 404s. That's good to know. All right. Let's make sure I've got the latest service worker this time. Posting to messages, not to message. That's there. I'll go back to application. This time we should only get one message, but I'll turn the Wi-Fi off. One more time. So we'll send that. Should be, as I said, there we go. Okay, it's even shown up in the database. That's cool. That's good to see. I'm going to do the closing the thing again. We'll go back to the phone screen. There we go. Turn the Wi-Fi on. This time, it got stopped with a 404 last time, but this time we should get that message through. And we should see it saying, come on, just in just a second. So I think that's cool. And so I wrote a blog post about it a while back, which actually has all of that kind of code in much greater depth with a better explanation. You can get it at a bit.ly URL, or I will post these slides with links in later, and I'll pop them on Twitter. But that's the background sync API. I'm pretty excited about what we can start to do with these things and where the future is heading, and I hope you are too. Thank you very much.